Hello everyone, very warm welcome to Arihant Online Academy, and here in this session we are going to discuss important MCQs on support vector machines with detailed explanations. Question number 1 is, what is the primary goal of support vector machine, that is SVM? So basically 4 options are here: classification, regression, clustering, or dimensional reduction. So everybody know that we use support vector machine for the purpose of classification. Here is its detailed explanation. Classification, right? So support vector machine is primarily used for classification task, where it aims to find the hyperplane that best separates different classes of data. For example, it is x-axis, it is y-axis, and if we want to classify, right, then we need to make a hyperplane, and this hyperplane will best describe that here it is a class A items, here it is a class B items. For example, if any particular mail is spam or not. So if spam, it would be under any particular class. If it is not spam, it would be any particular class, right? So such kind of classification task we use SVM. Question number 2. In an SVM, what are support vectors? Data points that lies closest to the decision boundaries, or data points from all classes, or data points that are outliers, or data points with the highest dimensionality. So let's describe it like that. For example, let's say this is our x-axis, this is our y-axis, and let's say this is the hyperplane. What it is doing, it is just classifying different items. Let's say it is class A item, it is class B. So data points that lie closest to the hyperplane decision boundary. So these are closest data points. Second is data points from all classes, all these points as well as all these points. Data points from outliers, extreme values, which is extreme, which are at the extreme end from the hyperplane, and data points with the highest dimensionality, means if the features are more. So what are support vectors? Basically, support vectors are the vectors which lies closest to this hyperplane, right? So here is the detailed explanation. Option A is the correct answer. Data points that lie closest to the decision boundary. Support vectors are the data points that are used to define the decision boundary of the SVM, right? They are the data points which are closest to the decision boundary and have the most influence on its position, because they are going to influence the results, and it should be extremely correct, right? Okay, so guys, do subscribe the video. Definitely, I hope whatever session we are going to conduct, every time you are going to get so much informative useful point from it, and definitely it is going to helpful for your upcoming every exam. So guys, do like the video, subscribe the channel, and stay tuned. Meanwhile, if you have any queries, doubts, confusions, feel free to comment, and be interactive. It is going to be helpful for you guys. Okay, so question number 3 is, the objective of SVM is, support vector machines objective, to maximize the margin between classes, to minimize the margin between the classes, to ignore the margin and focus on misclassified points, or to create a decision boundaries that passes through support vectors. So basically the correct answer is option A, that is maximize the margin between the classes. The main goal of SVM is to find the hyperplane, and this hyperplane should be like the margin between the different classes should be sit correctly. It should not like that whatever item belongs to class A are coming to class B, or class B coming to class A. So maximizing the margin between classes, this is the main goal. Option A is the correct one. Question number 4. In a linearly separable database, optimal hyperplane in SVM is the one which passes through the center of the data points, or maximizes the distance between support vectors, or minimizes the distance between support vectors, or creates the largest number of support vectors. So the question was, in linearly separable database, the optimal hyperplaces is who maximizes the distance between support vectors. Support vectors are the vectors which lies closest to the hyperplane. So to maximize distance between them. So the optimal hyperplane is SVM, that one that maximizes the margin distance between support vectors, right? Ensuring the best separable line. so that all the results should be the correct, right? Question number 5. What is the kernel trick used in SVM to reduce the dimensionality of data, or to increase the computational complexity, or to transform data into higher dimensional space, or to decrease the accuracy? So obviously we do not want to decrease the accuracy as well as we do not want to increase the computational complexity. B and D is out. Now A and C are left. To reduce dimensionality or to make it to the higher dimension. Option C, to transform data into higher dimensional space. So basically, the kernel trick is used to implicitly map data into a higher dimensional space, allowing support vector machine to find complex non-linear decision boundaries in the original feature space. Just advanced, right? So option C is the correct one. Question number 6. What is the purpose of regularization parameter C in SVM? To control the trade-off between achieving a low training error in a small margin, or to control the degree of polynomial kernel used, or to set the threshold for class separation, or to control the number of support vector. What is the correct? What is purpose of regularization? To control trade-off between achieving a low training error and a small margin, right? Option A. The regularization parameter C in support vector machine controls the balance between achieving a low training error and keeping the margin very small. A smaller C allows more margin violation, while a larger C enforces a strict margin and aims to minimize the training error, right? So you can also note these points along with the video. And if you require the PDF of these sessions, all the sessions which we are covering, data science and AI, or all the videos, if you require important PDFs on these sessions, the Telegram group link is mentioned in the section. Join that Telegram group. Regularly you are going to get the PDF of these sessions as well. Question number 7. What is the advantage of SVM over other classification algorithms? It is immune to overfitting. It works only on linearly separable data. It always performs well with unbalanced data set, or it is effectively high dimensional space and non-linear data. So the correct answer is option D. That is, it is effective in high dimensional data space as well as in non-linear data. That is what SVM advantages of. It works with linear as well as non-linear kind of data. So SVM can handle high dimensional spaces and non-linear data by utilizing various kernels to transform data into different feature spaces, making it highly versatile in different scenarios. That is why it is one of the biggest advantage of SVM classifier, right? Question number 8. Which kernel is commonly used for handling non-linear data? Non-linear data. Linear kernel? No. Polynomial kernel? Radial basis kernel or sigmoid kernel? Radial basis function, RBF kernel. Yes, the radial basis function, that is RBF kernel, is commonly used in support vector machine for handling non-linear data by mapping it into higher dimensional space and allowing a better separation of classes. Thus, C option is the correct one. Question number 9. What is the drawback of SVM in terms of computational efficiency? It requires a large amount of memory. Is this a drawback in terms of computational efficiency? Or it is not suitable for large data set? Or it is slow training time? Or it is sensitive to the choice of C? Basically, it does not require that much large amount of memory, as well as it is already suitable for large data set. It is one of the advantage which we can use it for, because we are making it to the higher dimensional now. And it is also not sensitive to the choices of C. The correct answer is, it has a low training time. The training time of SVM is low. It is one of the drawbacks. SVM can have relatively low training times comparative to the other classification, especially on large data set. Especially on large data set, as it handles large data set and non-linear data set as well, right? Due to optimization process involved in the finding optimal hyperplane, which makes the maximum distance between the support vectors, right? Question number 10. When should a soft margin SVM be used instead of hard margin SVM? So when to use soft margin SVM and when to use hard margin SVM? Option A, when the classes are perfectly separable, or when there is a small amount of noise in the data, or when the number of dimensions is small, or when dealing with imbalanced data set. So when we need to keep in mind about soft margin of SVM, right? when the classes are perfectly separable, when there is a small amount of noise, when the number of dimensions are small, or when dealing with imbalanced data set. So when there is a smaller amount of noise in the data, a soft margin should be used when dealing with noisy or overlapping data, as it allows for some misclassifications to achieve a more realistic and robust classification boundaries. Thus, option B is the correct answer for this. Now, in next chapter, we are going to discuss the next machine learning algorithm, which is based on GATE data science syllabus. So if you have any comments, arguments, any feedback, please feel free to provide it into the comment section and make this session more useful for the community. Have a nice day, guys. Jai Hind, Jai Bharat.